Good afternoon. I'm going to continue with the Carnot cycle engine, if you like, as promised. Just a few notes about, a few words about the way I present things. I try not to leave any stone unturned. I don't leave any unclarifications. What I hated when I was a student, I've studied a lot. So I used to hate it when somebody would say, it is easy to show that such and such a condition can take place. Such and such an equation is true. It is easy to show that. It's very common. When you see that, here are the reasons why that happens. Okay, at the best, it's because the guy is too lazy to do it. At the worst, and most commonly, it is that the guy or woman does not know how to do it. They're missing a piece of information. So I don't do that. Now I left one thing not done only because I haven't found a shortcut yet, and that is to work out why the gammas in general relativity have the form that they have, okay, in terms of the metric tensor. I haven't found a shortcut for that yet. I know how to do it, yes, but by long methods, really long and too long for a YouTube presentation, and that's no good. The thermodynamics, I did everything for you, but I did keep away from a lot of the partial derivatives. However, I might hit on the partial derivatives later when I start studying more entropy, which is coming up. What we're talking about is the Carnot cycle. Now I gave you Carnot's lifespan previously. He died quite young. Now cycle is the operative word and because we need a cycle, just the same as you have in a force extension graph for a spring, you need to have an enclosed area. So you need to go around the whole guy to make a cycle. The area under the figure is the work done. And as you guys know, the area inside the figure is the, well, it's a line integral, the work done. Never mind about that, we're getting a bit technical. So the Carnot engine, one way or another, is the most efficient. It consists of reversible steps. Carnot used two types of steps to make an enclosed figure. Roughly speaking, he has two isothermal steps and two adiabatic steps. Isothermal, adiabatic, I'll say what that means in a minute. Isothermic is a good word, could be isothermal, I don't care. Let's just do the cycle first, and then we'll have a look at let's see what we have a look at. We'll have a look at the efficiency of the Carnot cycle. First of all, we write down the efficiency for any engine. Is the work done divided by, okay. The work done divided by the amount of heat delivered to the coal reservoir. From the hot reservoir, sorry. Now this big Q is a lot of stuff, a lot of joules. This little Q, this big QC cold is a lot of stuff. But the little increments, delta Q and delta Q hot and delta Q cold, are delivered increments of work. Now we take an amount of, suppose we do 20 joules of work out of delta Q equals 100 joules. How many is left to go in here? 80 joules. So that the efficiency is 20 over 80, or following the formula, 1 minus delta Q cold over delta Q hot, which will give you the same result. Okay, so there are two, I'll let you get your heads around that first before I erase it. So for the Carnot cycle, what's he got? Carnot said this is the most efficient case. Now there are isotherms and adiabats. On a PV graph. Now the 1 over r curved is like this, and the 1 over r squared curve is steeper. So that's going to come into play here. Now delta T is T is a constant, so this whole thing is a constant. So isotherms would look like this. Now, an engine has to operate between two temperatures. Must operate between T hot and T cold because we need heat to flow. According to the second law of thermodynamics, heat only flows from a hot to a cold. We don't need this now. So we know what the efficiency is. Now T hot is the temperature of the hot reservoir, T cold is the temperature of the cold reservoir, and remember, the reservoir is a big source compared to the little deltas that the system looks at. Now for a PV diagram, these are isotherms, each at the same temperature, delta T equals 0, delta U equals 0, and so forth. Delta U equals 0, delta Q equals delta W. Okay? So delta Q equals delta W. The work done is the heat involved. For adiabats, delta Q equals 0. P, V to the power of gamma is constant. P, T, V to the gamma minus 1 is another constant. And gamma equals Cp over Cv. So, let's look at this case here. P is equal to C1 over gamma, and gamma is greater than 1, so it means that these guys are slightly steeper. Either one, both are reversible. So using the reversible processes of isothermic and adiabatic, Carnot constructed his engine. So he'll take an isothermal at T hot. And an isothermal at T cold. Excuse me. And he'll fill in the sides with an adiabat and another adiabat. So now, let's label the corners A, B, C, and D. Make a cyclic figure. Excuse me. Now we're going to make our engine go through its required cycle. We'll make it go this way. Now, what does that mean? Let's get rid of all that stuff first to explain what that means. Okay, so now, while we're talking about this, I'm very happy the way these talks are going. I do it off the top of my head. You know, what you see is what you get. And I don't get too many hits. Maybe someday they'll take off, but I don't really want too many hits. I often was involved in education, and education is fine, but I think physics shouldn't be included in it, okay? People should go away and find that out themselves. I think it's esoteric knowledge. And I think it's only for the privileged. Terrible way to think about things. But I was often at, especially high school, or even for college, how can we make physics more popular? We don't want to. It's esoteric knowledge. It's knowledge for the sages. And it's dangerous. We don't want the masses playing with it. All right, so here we go. Let's look at the different processes. Now, this direction is expansion. And this direction is compression. So whatever W you have, work done in that direction, it's going to be the negative going in this direction. All right? So here are the steps. For the Carnot cycle. First step, A to B. We have isothermal expansion, and you remember from my last lecture that the delta work, the work done, is also going to be the heat. And it's the heat exchanged from the hot, or extracted from the hot reservoir, and it's going to be nRT log VA over VB. Excellent. What D? Look at the diagram. T hot. I have a little T hot in there because I don't want to confuse the notation. All right, so from B to C, what kind of a process is that? Is it isothermal? That's the isotherm. That's an isotherm. This is an adiabat. Is it compressing or expanding? Check. It's still going this way. But no heat enters or leaves the system. But we can say that P V to the power gamma is a constant, T V to the gamma minus 1 is another constant. Now let's go to CD. CD is compression, but it's isothermal. But it's happening at the cold temperature. Remember, an engine must operate between a hot and a cold temperature. Carnot chose the reversible processes. Now, we put in our formula. Delta Q cold is the work done, CD, is NR T cold log VC over VT. First of all, I want to talk about this. Some people say N comes from natural logs. No, not really. It began with Naperian logs. Some people say E. It's not E. It's Napier's constant, okay? The little number E. Just to get that out of the way. However, let's continue with this one here. This work is going from left to right. This work is going from right to left. No matter what convention I use, I must give it a negative sign. Now, negative log x over y is y over x. So I'm going to write that in. I just reciprocal the two things. This is V cold. I leave it, VC. It's VC, it's not V cold. Okay, so now let's see. I hope you guys have a picture of that in your mind because I'm going to erase it so that I can get space to do more calculations. Now, I don't need to look at diagrams because I can keep the details in my head because it's rather trivial, but we need the efficiency. Now, you know I'm using absolute values. That's just a technicality. Don't worry about it. Now, we need the efficiency of the Carnot engine, and the efficiency of a Carnot engine is no different than any other engine. It's always 1 minus delta Q cold over delta Q hot, where delta Q cold is the heat delivered to the cold reservoir, and delta Q hot is the heat extracted from the hot reservoir, and the delta W is the difference between the two of them that happens somewhere in between. We need to work out this quantity for the Carnot cycle. Well, we have the results. Here's delta Q cold and here's delta Q hot. Now we have VD over VC and not C over D. And this is an N. I don't want it looking like a H. And we get this for delta QC. Now these two cancel. And we get this result. Now we're going to show that these two guys are equivalent, and we'll simply reduce to that. How do we do that? We go back to our adiabats. Now this is where some of the people on the YouTube make mistakes, and they get an accidentally correct answer because of it. We have to look at the two adiabats. Along this adiabat here, a certain thing is a constant, and along this adiabat here, a certain thing is a constant. And what are they? Well, let's go for this adiabat first. This is T hot. I better do that again because it's not clear. We don't need these things now. But we do need our diagram. I don't need it, but you guys need it so that you can see where we're going. Now the two adiabats are on the end. The two isotherms are the top and the bottom. Okay? We've dealt with the isotherms. We're now dealing with the adiabats. Well, from the first adiabat, this is T hot to T cold. I'll write CD for cold. Now V what? Well, it's going to be VB. The volume at this point. Down here, the volume is a volume C. So that's one result. Now let's go to the other adiabat, this one here. That's the worst adiabat I've ever seen. So we go from D to A, VD to VA, and T cold to T hot. V what? VD to VA. You got that? No. A. Now I'm going to note the following. No, I'll write it a different way. We have a situation like that. Call this 3q. 3q over 6 equals 4y over 3, but they're both to the power of x. That means that 3q over 6 equals 4y to the 3. I just can eliminate that whole thing. I don't need to even consider it, because that's going to come up. And in fact, the x will be a gamma minus 1. From this here, I can write a relationship, and I'm going to write 2. Actually, I'll do T cold over T hot. T hot and T cold are right here. Okay, let's divide both sides by T hot. They cancel. This is a B. They cancel, we get a factor of 1 in front of the VB. So far, so good. Now let's divide both sides by VC to the gamma minus 1. Well, that over that just gives me 1. And that's our first relationship. Now for the second equation, I get the exact same result. I get T cold. There it is. I'll divide by the TH and divide by the VD. And I get that following. Okay? So I get T cold over T hot also equal to VA over VD. Now they're all to the power of gamma minus 1, so I get the funny result that hence V over VC is VA over VD. Okay? I can rearrange this. I'm going to divide by the VB and multiply by the VD. Am I doing that right? VD over VC, VA over VB. And that's what I was chasing after. Why? Because now I can get rid of the diagram and use what we've got. I'll let you take that into your heads first. Okay, after that little bit of algebra, which one will I use? This one. Okay, let me get rid of the stuff that's giving you guys headaches. Which is giving you the biggest headache? I get all of this stuff here. That's the final result that I got, so I'm going to hang on to that. And I'll get rid of this, it's giving you a headache. And I'll write down my result. This is what we were looking for, and we found it equal to this. Now I hate writing ratios as a slant, but I'm just doing it for this particular case, so I almost never do that. But due to the adiabatic conditions, I've shown that VD over VC is VA over VB, so these two can cancel. So that the delta Q cold over delta Q hot for the Carnot case is just the ratio of the temperatures. Now this is an extremely important result, and I will use it to talk about the beginning look at entropy, and which will turn out to be quite interesting. Okay? But that's enough for this particular session. This is the Carnot cycle. This is its efficiency. And basically it consists of an isotherm and an isotherm with a T hot and a T cold, an adiabat and an adiabat. No heat is involved in these two guys. Constant temperature is involved in these two guys, and delta Q equals delta W for these two guys. And that's what we did. Okay? Excellent. Now I was saying it's esoteric knowledge. Keep it to yourselves. Don't spread it around. I don't want a million hits on this.